Hello everyone, welcome to my channel. Today we will be talking about an important topic, flip-flop conversions. Somewhere this topic is associated that we want to convert X flip-flop to Y flip-flop. First I'll talk about the number of steps which are used to do this conversion, and then I'll be exemplifying the same with the help of one or two examples. So I'll quickly start with the demonstration. Let us say we are being given that we want to convert X flip-flop to Y flip-flop. Now this X can be SR, JK, D, T. Similarly, Y can also be JK, D, T, SR. So any example can be given. So if you are getting such questions in examinations, somewhere what you are supposed to do, what are the steps? First thing is you will find out what is your available flip-flop. So what is given in the question? You want X to behave as Y. So what is available? Available is X. Then what is required flip-flop? Required is Y. Second step, I want X flip-flop to behave as Y flip-flop. Behavior means characteristic. So I will make characteristic table of Y flip-flop. What are the elements of characteristic table? Elements of characteristic table are whatever the name of the flip-flop is, those inputs, then present state, then next state. So we'll make one table known as characteristic table for Y flip-flop. Third step, we'll make excitation table of X flip-flop. What are the elements of excitation table? Qn, Qn plus 1 and name of the flip-flop. Then step 4 is we will merge table created in step number 3 with table of step number 2. So if you see both these tables, what is one common entry? One common entry is present state and next state. So these will be used as a merger one. Fifth is we'll make the K-map, and with respect to the equations, we'll try to make out the design. So these are the basic steps. What are the basic steps? Determine available and required flip-flop. Then make characteristic table of required, make excitation table of available, then merge both the tables, make K-map, and whatever is the output or the equation of K-maps, somewhere that is to be used for designing. So we'll be doing one question, and the question is convert JK to D. So, as per the above discussion, step 1, available is JK flip-flop, required is D flip-flop. Step 2, what does the question says? Question says, I want JK to behave as D. So, we'll make characteristic table of D flip-flop. What are the elements of characteristic table? Name of the flip-flop, present state, next state. Now, input is 1, input can be 0, input can be 1. For this 0 input, present state can be 0, present state can be 1. For this 1 input, present state can be 0, present state can be 1. So if I complete the table somewhere, this is how the table appears. Now, for a quick reference, D flip-flop is known as data flip-flop. When I say so, if D is 0, output is 0. If D is 0, output is 0. If D is 1, output is 1. If D is 1, output is 1. Somewhere D flip-flop is not dependent upon present state. Next state is always equal to D. So this is the characteristic table. Step 3, we are supposed to make excitation table. And excitation table is always made for the available flip-flop. What is available? JK. What are the elements of excitation table? Present state, next state, J and K. For two inputs, values will be 0, 0, 0, 1, 1, 0, 1, 1. If you make the characteristic table, somewhere you will get that whenever present state and next state are 0, 0, 0, 1, 1, 0, 1, 1, somewhere J works as 0, 1, cross, cross, and K is reverse to it, cross, cross, 1, 0. Right? How do we get this table? Excitation table is always made from characteristic table. For the meantime, we are just making the quick entries, and this is how your table appears. Step 4, merge. What I need to merge? I need to merge 3 into 2. So first I'll make table 2. Then what are the entries left behind? These are the entries left behind. Now let us complete the table. 0, 0, 0, 1, 1, 0, 1, 1. How does D behaves? D behaves as data. And now you will find from here 0, 0. Try to find out it in this table. For this 0, 0 value is what? 0 cross. Next entry in this table is what? 1, 0. 1, 0 entry is cross 1. Next entry is what? 0, 1. What is the entry of value of J and K? 1 cross. Then last comes 1, 1. Somewhere for 1, 1 the value is what? Cross 0. Moving ahead with the same. Step number 5. Make K map. 1 K map for J. 1 K map for K. What are the input elements? Input elements are D and Qn. So somewhere I'm completing the K map entries. Similarly making 1 K map for K2. Input values are the same. Now I'll be plotting the minterms. Somewhere J is don't care at 1, J is 1 at 2, J is don't care at 3. Similarly, K is don't care at 0, K is 1 at 1, and K is don't care at 2. So if I'm supposed to make the groupings, these are the groupings, and if I go by the groupings, J is equal to D and K comes equal to D bar. Now we'll be designing it using this K map equation. Somewhere the circuit diagram is what is available to me. Available is what? JK flip-flop. So I'll make one box, name the inputs JK, other inputs are QN and QN bar. Then flip-flop is not existing if you do not give clock. Now I am having one variable D, J gets D, K gets D bar. So this will be the circuit diagram for the given conversion. And which conversion we did? We did convert JK to D. I'll soon be coming with few more conversions.